So today we're going to be expanding on our general concept that we started yesterday, which is factoring. And more specifically for 7.2, we're going to be factoring trinomials. Now, it should be mentioned in here, we're going to work with a very, very specific type of trinomial, and we do get a more generalized process in 7.3. One that you'll probably end up using a lot more than you will this method, because this method is encompassed within the 7.3 material. That being said, I believe 7.3 is one that's covered in the next class. So this is a nice preview into factoring that you'll be seeing more examples of and more work with in the next math class that you take. But for now, we're going to go through our process that we're going to have for factoring trinomials. Now, we're working with trinomials primarily in the form of x squared plus bx plus c, where b and c are integer numbers. So very specifics here, we have just 1 as the scalar for the coefficient for x squared. X has some number in front of it, and c has some number value attached to it. So our general process with this, of how we're going to factor this thing, we want to write the factors as two binomials with the first terms of x. So we're always going to get something, if we have an answer, in the form x plus or minus a number times x plus or minus a number. The numbers could be the same, they could be different, they could be positive, they could be negative, we don't know. We're going to start with making think of it as the shell, air quotes, of our final answer. Parentheses with an x, parentheses with y, and then we'll add on to that at the very end as we go through the process. It should be noted that we can see different variables in here than just x. It could be y's, it could be n's, it could be t's, it could be anything like that. We're just going to list our original variables for the problem first. So now, this is the next part that kicks in and how we're going to find our answers to these things. We need to find two numbers, m and n, just using that in the general terms, that multiply to equal c, which we have given to us here, and add together to equal b, we have right here. And we'll go through, I think this is the trickiest part with this process, is figuring out what are those two numbers going to be. And thankfully I have a couple tricks I think that will help out with going through this. You're welcome to use them. You're welcome to find your own. I think it's just want to give you guys a lot of options at your disposal to go through and solve these things. It should also be noted that m and or n could be positive or negative based on the b and c values. It's going to introduce something that's called sign analysis when we go through and do this step in our process. But thankfully, there's a fairly, I think, mechanical process to go through and find these values, which we'll go through with a couple examples. So at this point in time, once we have found m and n, we use m and n as the last terms in the factors. So we just plug m in here, plug n in here, just like what we had from up here, including their signs, and then we are done. We have fully factored the trinomial that we are working with. We can check our answer by multiplying these two factors together using the distributive property, like we did in, was the chapter 5 material? Chapter 4. It's one of those two. I'm forgetting off the top of my head right now. But in the chapter 4, chapter 5 material where we're working with multiplying polynomials together, that's what we're going to be doing here with these, if you would like to check your answer. Now, I have a little bit of it detailed out here, but we'll go through examples with this as well. When you're doing step 2, I recommend listing the factor pairs of C. I think it's particularly helpful because it helps us determine all numbers that multiply to get C, and then we just find which ones add together to get B, which is really nice. While we're doing this, determine which one or maybe both of the factors are positive or negative. At this point in time, we're going to go through and do some sign analysis to find that out in our heads, which again, we'll go through an example of. And sign analysis, I think, it sounds a bit scarier at first than I think it actually ends up being in a lot of respects, if we organize our work. And again, be very organized in this step. if we use a little bit of organization at the front end, it can make the rest of this very, very, very easy. Okay. And it can be the case, it's not unheard of this happens, if we are unable to factor a polynomial, it is considered to be a prime polynomial. So you may just list the answer as prime, prime polynomial, something like that. Either of those two terminologies will work. That being said, I would recommend and giving you guys this warning, do not jump to the conclusion that a polynomial is prime just because some of the numbers become a little difficult to work with. We can have fractions showing up, we can have decimals showing up, but just because we have fractions or decimals doesn't mean that we can't necessarily factor this thing. So be very, very, very cautious with jumping to this conclusion that it's a prime polynomial just because the numbers get a bit gross. It's very, very slippery slope to fall into, and it doesn't really end well if we do that. Okay. So we're going to go through 4 examples of using this process, and I'll show you guys what I mean specifically with step 2. This is the really important one, of how we go through and find the 2 values that we're going to work with. So these are the 4 examples that I'm going to reference over on our Blackboard. So let's jump on over there and take a look at these. Okay, so our first example, and again, we're told to factor this thing. We're starting with, zoom my other screen in here so I can actually see what I'm looking at. There we go. Okay, so we're starting with x squared plus 11x plus 24. We want to factor this thing as best we possibly can, fully factor the polynomial given to us. So again, following our process, write the factors as 2 binomials with their corresponding first terms, which is going to be x in this case. So what we can do for ourselves is say, okay, well, if I get something that can factor, and I get x plus or minus something times x plus or minus something else. We're going to fill in these blank spots here once we have our m and our n value, or other 2 numbers that we're going to find here. So going into step 2, we need to find 2 numbers, m and n, that do 2 things. They multiply to equal our c value, and they add together to equal our b value. So some of the things that people like to do, and I'm totally on board with this because it's very helpful, is list for themselves what is the b value and what is the c value of this polynomial. Well, our b value is 11, based on the general form that we're going to be working with here, and our c value is going to be 24. When you are doing this, I would highly recommend, again, detail this out for yourself, put that extra bit of clarity on there, labeling my b value is this, my c value is that, anything along those lines. Make sure you are including the sign in that as well, whether something is positive, where something is negative, for our b or our c value. It's very important that we have that for ourselves. Now, here's the trick that I think makes finding the m and the n value to plug in to our problem, our final answer. Here's a method that I think is particularly helpful with this. So what we're going to do is we need to find 2 numbers that multiply to give me c and add together to give me b. So let's start with listing all of the numbers that multiply together to give me my c value. It's 24 here. So here we're going to list the factor pairs of 24. When you're doing this, I highly recommend you organize it this way. Put all of the small numbers on the left, put all of the large numbers on the right. What I mean by that is when we're listing the factor pairs, do something to this effect. 1 times 24. Those are 2 numbers that multiply to give us 24. 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, 6 would work, but 6 is already listed, so I am done. I have just listed all of the numbers that multiply to give me 24. So I have a whole list of options that I could use for an m or an n value. Now I need to determine, this is going to become much more important when we have negative signs showing up, which of these columns of numbers are going to be positive, which ones are going to be negative. And here's where the sign analysis is going to kick in here. So we're taking a little bit of a step back to determine whether all of these numbers are positive, all these numbers are negative, if one column is positive, if one is negative, something like that. So what we're going to do, let's take a look at our B and our C values, and let's think a little bit detached from this problem for a quick second. For my C value, the answer is a positive number. So that tells me that the column of numbers that I have listed for myself as the factors of 24 here, the only way that these could multiply together and give me a positive answer is if both numbers are either positive or both of the numbers are negative. So we know that both columns of numbers are going to be the exact same sign. They're both positive or they're both negative. If we take a look at our B value, that tells us that when I add these two things together, my result should be a positive number. So from C, I've determined both of the columns have to have the same sign, positive or negative. From B, I've determined that when these things add together, I get a positive result, therefore telling me that the numbers in both of these columns are going to be positive. And again, this is going to be abundantly clear and very, very helpful when we get into future examples, but the sign analysis that we just did here is going to be absolutely crucial to help with some of these future problems. And again, we'll be able to see this in some future ones as well. So now I'm going through and I'm trying to determine, okay, all the numbers in the left-hand column are positive, all the numbers on the right-hand column are positive. Now I just need to find which pair adds together to give me 11. So some people like to do this, and there's nothing wrong with it. Off to the side, they put, what is 1 plus 24? It's going to give me 25. 2 plus 12, that's going to give me 14. 3 plus 8, that's going to give me 11. Bam, I just found it. We could continue on the last one, but we don't need it. So we've just found our M and our N values that multiplies to give us 24 and adds together to give us 11. So we have our M and our N value. Now we can go back up to our problem and write in our two answers there. And at this point in time, there's nothing else we can do to factor this thing any further. We have our final answer, and we are done. What I mean by BC value is based on our, jump us back here to our notes. Our B and C value we have right here, we have right here. So the B value is the number that's right in front of X, and the C value is the constant at the very end. So we'd like to, I think it's very helpful to go through and actually label this 11 is my B value, this 24 is my C value. Because we absolutely need both of those, we need to correctly identify both of those to go through and factor these types of problems. So moving on to our next example with this, again, following a very similar process, but I want us to have a lot of examples, or at least a few examples to reference when we get to the homework and beyond that. So our second example has us being given t squared minus 9t plus 18. So again, just like we did with our previous problem, if we can factor this, let's write the general form of our answer. So it's t plus or minus something times t plus or minus something else. We have the general shell of our final answer written out for us. Great. We now want to correctly identify our B and our C value from this equation. Again, going back to our general form. So our B value is going to be this negative 9. Remember, in front of the t that we have here. And the c value is going to be 18 at the very end. The c value right here. Now we need to go through and we need to find two numbers that multiply to give us c and add together to give us b. So again, I think it's very helpful. List all the factor pairs of 18. And then we'll do sign analysis afterwards. Always start with one and the number. A lot of people miss that and it costs them points, and you don't want to do that. So start with 1 times 18, then count up on the left-hand side. So 2 times 9 should work. Then we have 3 times 6. 4 doesn't go into 18, 5 doesn't, 6 does, we already have it listed, so I'm done. I have all of the factor pairs of 18 listed out for myself. Now I need to do sign analysis. We have the smaller numbers on the left, larger numbers on the right. Which column is going to be positive? Which one's going to be negative? Will they both be positive? Will they both be negative? That's what we need to figure out for ourselves. So once again, our first clue is going to come from our c value. Our c value is positive, which means that when I multiply these two factors together, our result needs to be a positive number. That tells me that both of these columns are going to be the exact same sign, because a positive times a positive is a positive answer, and a negative times a negative is a positive answer as well. So I know that both of these columns need to have the exact same sign to them. I don't necessarily know which it's going to be based on the c value. This is where we look to our b value, and that's going to tell us what we're going to use. So c tells me that they're going to be the same. They're both positive or both negative. My b value tells me that when I add these things together, I get a negative answer, which means, that's the giveaway hint, of both of these columns must have negative numbers, because I can't add a positive number and another positive number and get a negative number. But I can combine a negative number with another negative number, and my result will be a negative number. So I know both of these columns have negatives in them. And again, now we can go through and determine, okay, so when I add these things together, what are my results? So -1 minus 18, -19. It's not what we're looking for, but that's fine. -2 minus 9, it's going to be -11. Getting closer, but still not that one that we're looking for. And then -3 minus 6, minus 9. Hey, that's the one that we needed. That matches our b value. So from there, I have just found my m and n values, are the two numbers that I need. And I'm going to write those in to our final answer. Make sure you are including the sign with those as well. So I'm going to get t minus 3 and t minus 6 for the final answer. Now we'll touch base on this now, because this normally comes up around the second or third problem that we go through. I get the question fairly regularly, it's an understandable one. Is there a specific order that we need to list these binomials in? Meaning, do I need to have the negative one listed first? Do I need to have the smaller value listed first? Anything like that? And no, you do not. As long as one of the terms, using our first example here, as long as one of the terms is x plus 3 and the other one is x plus 8, I do not care the ordering that you put these in. Same thing goes with the second problem. You could put t minus 6 as the first binomial and then t minus 3 as the second one. This ordering does not matter. Make sure that you at least have the number and the correct sign in those. That's the main part that we're worried about. But the way you order these doesn't matter. It's the nice part about multiplication. Order doesn't matter. Let's take a look at another example here. This is one where we start to see some of the, I'd say a little bit of the weirder stuff showing up with sign analysis, but we still want to see examples of it. Okay, so for example 3, we are starting with y squared minus y minus 20. We're told to fully factor this thing. So again, we're going to start with making the shell of our final answer. So y plus or minus something. Give us a bit more space here. There we go. Times y plus or minus something else, if we're able to get an answer. Now, once again, as we've done with our previous problems, we need to find two numbers that multiply together to give us our c value and add together to give us our b value. So again, let's correctly identify what our b value and our c value is based on this general equation we've been given. So b is going to be -1. Remember, it's that thing directly in front of the y, that invisible 1 hanging out there. And our c value is going to be -20, just this guy on the very end. Make sure when you are doing this, you are including the sign in there as well. It's absolutely crucial, especially for our next step that we're going to go through with our sign analysis. So now I need to find two numbers that multiply together to give us c and add together to give us b. So let's start with listing the factors of -20. And again, the organization with this step is absolutely crucial if you want to be able to make this a very mechanical process. Always start with and put the smaller numbers on the left-hand side, and then slowly count up as you're listing the factor pairs. Okay. So I've just listed all of the factor pairs of -20. Now I need to determine which column is positive, which column is negative. Are they both positive? Are they both negative? Something like that. So this is the main example of where organizing this thing is crucial. With our C value is negative. So that tells me that the signs of these columns are different. And the reason behind that is if the numbers are the exact same sign, a positive times a positive gives us a positive answer. A negative times a negative gives us a positive answer. But our answer that we're working with is negative, which means one of these columns has to be a positive number. One of these columns has to be a negative number. When we think back to our generalities of working with signs, when I have a positive times a negative, I get a negative answer. If I have a negative times a positive, I will get a negative answer. So the C value tells us that one column is going to be positive and one value is going to be negative. Again, I don't know which one yet, but that's all the C value tells us with the sign analysis. If we have organized our factors of 20 in this way, with all of these small numbers on the left and all the large numbers on the right, then our B value, the sign of our B value specifically, is going to be the sign of the larger value column. So our B value is a negative, which means all of the larger numbers have to be a negative, and the small values have to be positive. And the reason behind this, again, we can think on it here for a quick second in the abstract, and then we'll see the numbers for it. If I'm adding two numbers together, and my result is going to be a negative number, it stands to reason then that of the two numbers I'm working with, the larger number has to be negative, because that will give me a negative result when they are officially combined together. And we'll see this play out when we're now combining these things as we're finding our B value. So if I have a positive 1 minus 20, I get negative 19. If I have a positive 2 minus 10, I get negative 8. And then if I have a positive 4 and a minus 5, I'm going to get negative 1, which is the thing I'm looking for. So I have just found my two values that I need. And now I can plug that into the shell of the final answer that we had. Y plus 4, y minus 5. And again, the way you order this, it doesn't matter. You could have y minus 5 in front, and then y plus 4 is the second thing. That works just fine also. But one of them needs to be y plus 4, one of them needs to be y minus 5. We'll take a look at our last example from this part of this section. We are going to be seeing more examples like this, by the way. I will let you guys know about that right now. The next part of this section has us doing a very, very slight modification to this process, but we will be seeing more examples with this here shortly. So if you're looking for more beyond the first 4 that we're doing here, just hold tight. We've got more coming. Okay, so looking at example 4 here, okay, we've got our trinomial here. We don't know what we're going to get for our final answer, but let's list our, again, shell of an answer in here. We have an n plus or minus something times n plus or minus something else. Okay. Let's correctly identify our b and our c values. B is going to be negative 10, and C is going to be 12. Just like we've done with our previous examples. Now we're going to be listing the factors of 12 to find 2 numbers that multiply to give me my C value and add together to give me my B value. So 1 times 12, oops, 2 times 6, 3 times 4, 4, and repeating. Okay. So let's do this sign analysis again. My C value is positive, which means that both of these columns are going to have the exact same sign. My B value is negative, which tells me that when I add these two things together, I need to get a negative answer. So if both columns have to be the same sign, and when they add together, my result should be negative, that means both of these columns are going to have negative numbers for them, for their signs. Oops, there we go. Now I'm going through and saying, okay, well, let's add these things together and see which ones add together to give me my B value of negative 10. So negative 13 doesn't work. Negative 2 minus 6, it's going to give me negative 8. Negative 3 minus 4, it's going to be negative 7. And now, suddenly as I'm looking through this, I have no values here that add together to give me my B value. Which tells us, because I'm getting that scenario showing up, I cannot factor this thing, which means I'm not going to have an answer that can be factored out. Instead, I have a prime polynomial. Which means I cannot factor this thing at all. I am done. Can't do anything else with that. So again, make sure if you're going to be labeling something as a prime polynomial, which again does show up, it's not uncommon, make sure you go through the entire process. Make sure you have every single factor pair listed out, because a lot of people will miss 1 or 2 factor pairs and then suddenly that might be the one that they're missing. Make sure we've listed all the factor pairs. We've done all the number crunching to see what that creates for us. If nothing works on that front, then we have a prime polynomial and we can't do anything else with this thing, and we're done. Okay. So those are 4 examples that we have with working with trinomials of the form x squared plus bx plus c. So again, a squared plus a number times the variable, and just a constant at the end. So that same form for all of these. Again, the numbers might be different, the signs might be different, but the process is the exact same way we're going to go about solving it. Okay. Let's zoom us out here because we're going to go through more examples, but divide this thing up here first. So let's jump on over back to our notes, and we'll take a look at the second half of this section. So we just went through our first part, and we went through our examples that we have listed here. Now we're going to get to trinomials of the form x squared plus bxy plus cy squared. And essentially all this is saying is we're now throwing an extra variable, an extra unknown into our equation. What's really nice though about this is while this may look big, scary, and intimidating at face value, nothing is really going to change with our process. We're going to follow the exact same steps as were originally mentioned up above. Here are the only variations that we're going to have. Because we have an x and a y variable showing up in our problem, in step 1, instead of just listing x plus or minus a number times x plus or minus a number, the only difference now is that we're going to have x plus or minus something times y, and then x plus or minus something times y for our second term. That is quite literally the only difference. In step 3, where we have it listed as our answer is x plus m and x plus n, the only difference now is that we're going to have x plus m times y and x plus n times y. So all that's going to change is in our final answer, in our shell of an answer, we're going to have a y showing up at the very end there, or nothing else, our second variable that we are working with showing up at the very end. Everything else stays the exact same. Doing the sign analysis, finding that m value, finding that n value, all of that stays the exact same. So this is one that I think looks deceptively different from what we were just working with, when it turns out we're actually not really changing much of anything at all. So we're going to go through 4 examples with this, and we're going to find that, again, the sign analysis portion in step 2, pretty much doing the exact same thing. We actually are doing the exact same thing here. So we still get to see more examples of this. Again, this is universal for working with it when I have 2 variables and when I just have 1 variable showing up. Okay. So we're going to go through these 4 examples over on our Blackboard. So I'll jump us over there now. Okay. There we go. I get my other screen adjusted here so I can actually see the problems that we're working with. Okay. So our first example that we have with this one, we're starting with x squared minus 13xy plus 12y squared. Okay. So once again, let's build the shell of our answer. Let's assume that we can factor this thing. If we can't, then we'll do what we did with the last problem. I just write it as a prime. But let's assume that we can get an answer. So again, the shell, x plus or minus something times y times x plus or minus something times y. So we'll fill in the blank space in here once we find the 2 numbers that we're working with. But otherwise, this is the first difference between this process and the previous process that we went through. We're just putting the other variable in our final answer. That's it. Now, just like with our previous ones, we're going to correctly identify our b and our c values. And they're the exact same, they are in the exact same spots as they were previously. So our b value in this thing is going to be negative 13. This guy right here. And our c value is going to be the number at the very end of the problem. It's going to be that 12 we have right here. Yes, they are attached to some variables by multiplication. That's fine. We're still identifying b and c the exact same way, just like we have there. So now we're going to go through the sign analysis just like we did with our previous 4 examples. So I want to find 2 numbers that multiply to give me 12 and add together to give me negative 13. So let's list the factor pairs of 12. 1 times 12, 2 times 6, 3 times 4. The next one will be 4, and that repeats, so I'm done. So now I'm looking to sign analysis. My C value is positive, which tells me that both of these columns of numbers should either both be positive or both be negative. That's all the C value and its sign can tell me. Looking at the B value that I have, I get negative 13 as my result. So both of these columns need to add together to give me a negative answer. Then both columns have negative numbers attached to them. So now I can go through, try adding these things together and see what I get. So negative 1 minus 12, negative 13, bam, that's what I'm looking for. We could go through and list out these last ones if we wanted to. It's not really required once we've found what we're looking for, but you're welcome to do so if you'd like. So we just found our two numbers that multiply to give us 12 and add together to give us negative 13. And now that I have those, I can go back up to my general answer and I can put in, there we go, negative 1. Don't need to explicitly write that 1 in. If you'd like to, you can, but you don't have to. So I get x minus y times x minus 12y. And that's going to be my final answer. So again, not much is changing in our process, if anything, really. The only difference is we're going to have another variable in our final answer. But as we're seeing with the process that we actually went through to actually factor this thing, that extra variable in there did not affect anything in our process with finding the B and C values, with doing the sign analysis, any of it, which is nice. At least I think so. It's one less thing we have to keep, one last extra process to keep track of. Let's take a look at another one. So our second problem that we have, I'm going to do a slight modification to how it's written on our paper here. I'm just going to do x, y again, but I am working with the second example. Okay, so we have x squared plus 3xy minus 10y squared. Again, I'm changing the variables slightly from the original problem as it's listed. So again, following the exact same process, I'm assuming I can factor this thing, so let's try and make that happen. So I'm going to get the shell of my answer, x plus or minus something times y, times x plus or minus something times y. Now we're going to correctly identify our b value. So our b value in this case is going to be 3. Our c value is going to be negative 10. And now we need to list the factors of negative 10 and then do some sign analysis of those numbers as well. Listing those things out, negative 10. I have 1 times 10. I have 2 times 5. 3 doesn't work. 4 doesn't work. 5 works, but I've got it listed, so I'm done. So now we need to do sign analysis. Which column is positive? Which one is negative? Are they both positive? Are they both negative? So our C value gives me a negative answer, which tells me that when I multiply these things together, my result should be negative. So that means one of these columns is positive, one of these columns is negative. And if we have organized it in this manner, again, small numbers on the left, large numbers on the right, then the sign of our B value tells us the sign of our larger column, Because again, if I add these things together, one's positive, one's negative, but if I add these things together, I should get a positive answer, which means that the larger number has to be a positive number as well. So now we can go through. -1 plus 9, that's going to give, or plus 10, that's going to give me 9. Spoiler there. -2 plus 5, that's going to give me a positive 3, and that's what I'm looking for. So I've just found the factor pair that I need to use. This guy here, there we go. So now that I have the two numbers that I'm working with, I can go back up to my shell of an answer. I can say x minus 2y times x plus 5y. And I have my answer there. So again, I think a lot of these become very mechanical as we're going through this process. At least that's the very nice part about this portion of factoring. We got the very generalized version of this in the next section, which I believe is going to be in the next class. Actually, I'm pretty sure it is in the next class. This is a very good stepping stone and starting point for a lot of these types of problems, at least with factoring. I picked the negative positive again. We're going to go through that with the, we got two more examples where we can have that showing up. So we'll get to that. So looking at example 3, again, I'm going to change the letters up a little bit, the variables up, but we'll have the same basic answers with these things. Let's use m squared minus 11mn plus 10n squared. Okay, so again, I'm going to assume I can factor this thing. So if I can, m plus or minus something times n. Build that shell for yourself. Next, we need to identify our b and our c values. B value is -11. C value is 10. Again, that B value is coming from right here. C value is coming from right here. Next, I'm listing all of the factor pairs of 10, and then we'll do that sign analysis with these. So factor pairs of 10. 1 times 10, 2 times 5, 3 doesn't work, 4 doesn't work, 5 works, but I already have it listed, so I'm done. Now sign analysis. Always look to your C value first. That tells you if the signs of the columns are going to be the same or different. So if our C value is positive, that tells me the columns are going to be the same sign. The C value does not tell us which sign they will be, but it tells us whether they're going to be the same or different. So with C being a positive value, there's no negative in front of that, so C is a positive 10. That tells me that both of my columns are going to either both be positive or both be negative. That's all that C can tell us. I look to the sign of my B value, -11. And if both of these signs, both of these columns have to be either positive or negative, and I know that the result when I add them together is a negative number, that tells me that both of these columns have to have the same sign, and that sign is negative. So from here, now I can add these things together and find which ones combine to give me my B value. So -1 minus 10, it's going to give me -11, which is the thing I'm looking for. Yay. Did the last one just to make sure we've got it completed, but you don't have to do that if you found which one works. So we've just found our factor pair. So it's going to be -1 and -10. So we can write this out in our shell as m minus n and m minus 10n. And minus 10n. Oops, there it is. And there we have our process for that. We do have one more we're going to go through. I'm going to let this sit here for a quick second. Okay, so we'll move on to our fourth example. I'll give you guys here, as we're going through this, I'll take a couple extra pauses here, so I'll let you guys attempt to work through part of this at the same time. Okay, so we're starting with the trinomial m squared minus 8mn minus 9n squared. And again, let's make the shell of our answer m plus or minus something times n times m plus or minus something times n. So we've got our shell of an answer. Fantastic. We need to find out what our two values are that we're going to be plugging in there. So we're going to go through this in a little bit slower pace. So I want you guys to be working through this and trying this on your own as we're going through these. So you need to correctly identify our B and our C value. Don't need to type anything in. I'll give you guys about 10-15 seconds on your own. What is the B value? What is the C value? Again, you don't need to type anything in. You don't need to unmute yourself. Just think for yourself as we're going through these things. What's my B value? What's my C value? And if you said the B value is -8 and the C value is -9, you are correct. So next, we need to list the factor pairs of -9. So what numbers multiply together to give me -9? So go with all of this, do this on your own, and then I'll go through this. So go ahead and take about 10-15 seconds or so. List out the factor pairs, all of them, of -9. Again, you don't need to type anything into the chat. Just do this on your own. Okay, and we should be getting 1 times 9 and 3 times 3. It's the only factor pairs that we have. So now we're going to do the sign analysis portion of this. Again, we look to our C value first. So that tells us if the signs of the columns are going to be the same or if they are going to be different. So take a quick second, think on it, think of our previous examples. Are the signs of these columns going to be the same or are they going to be different? And based on the sign of C, which is a negative number, that tells me that the signs of my two columns are going to be different from one another. One is going to be positive, one is going to be negative. Based on that, then, I need to look to my B value. Which column is going to be positive and which column is going to be negative based on the sign of our B value? So let's go ahead and think on that. So based on the sign of the B value, which is negative, and if we organized our table with these small numbers on the left, larger numbers on the right, then that tells me that the sign of the left-hand column, the smaller column, or smaller numbers, are going to be positive, and the sign of my larger numbers, the right-hand column, are going to be negative. And now we need to determine which numbers, when added together, will give us a result of negative 8. So when I do this, I have a positive 1 minus 9. That's going to give me negative 8. That's the thing I'm looking for. Fantastic. My second one gives me a value of 0, which is fine, but it's not the thing that we need. Here's my factor pair. And now I can go up to my general answer and write those in. And I have my final answer here. Didn't box it. Why not? There it goes. And there we have our final answer for this problem. So this is everything that we have for the 7.2 material. And 8 examples of pretty much the exact same process. Again, the only difference between our last 4 from our first 4 is that we're just writing in another variable into our final answer. That's it. It's literally the only thing that changes. Everything else stays the exact same as we did previously above. So that's everything for these two, well, not these two, but these two parts of this single section. So I'll go ahead and end the recording here.